You know what's crazy? Think about the very first thing you did this morning. You probably grabbed your smartphone, checked the weather app, maybe sent a quick text, or just mindlessly scrolled a newsfeed. We take this instant global connection completely for granted, but the invisible infrastructure that makes literally all of that possible is floating hundreds, sometimes thousands of kilometers right above our heads. Welcome to this explainer, where we're going to unpack the incredible historical drama of exactly how we went from just staring up at the sky to putting intelligent machines into orbit. It's a wild story full of rapid innovation, intense rivalry, and some truly breathtaking scientific leaps. Let's get into it.
All right, so the modern satellite network that we rely on today is often affectionately called an orbiting radio star. It's basically this highly complex machine that efficiently bounces signals all across the globe, allowing two totally distantly located stations on Earth to communicate seamlessly. But, long before these sophisticated arrays of solar panels and antennas existed in reality, they were nothing more than bold, theoretical concepts just mapped out on paper. Getting from that paper to actual orbit? Well, that required an unprecedented technological explosion.
Now, before we get too deep into the history, let's quickly clarify what we're actually talking about here. By definition, a satellite is really just any natural or artificial body moving around a celestial body. For our journey today, obviously we're focusing on artificial satellites orbiting Earth. They basically act as repeater stations for our signals or as explorers mapping our atmosphere and beyond. They are quite literally our eyes, our ears, and our voices in the sky, performing their designated roles throughout their entire operational lifetime.
And honestly, this quote right here perfectly captures where the spark for all of this came from. Back in October 1945, the science fiction writer Arthur C. Clarke published an article in Wireless World magazine. And he proposed something totally revolutionary for the time, a geostationary artificial satellite. He calculated that if you put an object at a very specific radius from the Earth's center, its orbital period would exactly equal the time it takes the Earth to rotate. So to an observer on the ground, it would look completely static, providing uninterrupted communication. To leap from the pages of science fiction to tangible reality is just mind-blowing, and this visionary quote officially kicked off the space age in the minds of scientists and technologists.
Section 1. Concept to Countdown. So how exactly did we get from a magazine article to actual metal up in the sky? Well, in the late 1940s, theoretical ideas met the explosive, incredibly dangerous reality of early rocket science. What you're seeing here is the sheer raw power of an early A4 sounding rocket launch in 1946. Now, these rockets were originally designed during the Second World War as explosive delivery systems, but they were quickly repurposed by scientists for the aerial observation of the Earth's upper atmosphere. In May 1946, a heavily modified A4 rocket was launched carrying scientific instruments up to an altitude of 112 kilometers just to record cosmic ray flux. It was literally our very first technological reach into the fringes of space.
Section 2. The Soviet Surprise.
So for about a decade there, from 1945 to 1955, the primary focus was just on these sounding rockets and even hot air balloons. The US and Russia both announced plans in 1955 to eventually construct and launch artificial satellites, but progress was pretty quiet. And then, the space race went from zero to a full-on sprint. Just look at this frantic ping-pong match of technological leaps between the United States and the Soviet Union in the late 50s. Within a span of just 2 years from their initial announcements, we see a rapid succession. Sputnik 1 and 2 in late 1957, the American Explorer 1 in early 1958, Vanguard 1 shortly after, and then Sputnik 3. It was this astonishing period of back-and-forth innovation that absolutely gripped the entire globe.
And here it is, the machine that actually started that sprint. Sputnik 1, launched on October 4, 1957, by a Soviet R-7 intercontinental ballistic missile. Notice that sleek spherical design? It was relatively simple, really, designed primarily just to provide information on the density and temperature of the upper atmosphere. But as it orbited the Earth every 96 minutes, its little radio beeps completely shocked the globe and officially brought the space age to life.
Now, the Soviets definitely didn't just sit back and celebrate, they immediately pushed the boundaries again. Less than a month later, in November 1957, they launched Sputnik 2. And this mission achieved a massive, almost unbelievable biological milestone. It carried a dog named Laika, making her the first living creature to ever orbit the Earth. This just highlights how incredibly fast the Soviets were iterating on their initial success, rapidly moving from simple atmospheric testing to studying the actual biological effects of orbital flight.
Section 3. America enters the race.
So obviously caught off guard by the Sputnik launches, the Americans rapidly accelerated their own efforts. And this intense rivalry acted as a massive catalyst for global scientific progress. Check out the totally different design philosophies that emerged here. On the left, you've got the Soviet spherical Sputnik 1. On the right, the American Explorer 1, launched in January 1958. Notice how Explorer 1 is pencil-shaped? That wasn't just an aesthetic choice. That design allowed it to spin like a bullet as it orbited the Earth. That spinning motion provided gyroscopic stability to the satellite while it was in orbit, a technique known as spin stabilization, which, by the way, remains a fundamental concept in aerospace engineering even today.
But listen, these weren't just political trophies to show off. They were serious scientific instruments that radically changed our understanding of our own planet. Explorer 1 discovered that the Earth is actually girdled by a trapped radiation belt. And Vanguard 1? It revealed a pretty quirky fact. The Earth isn't a perfect sphere. It's actually slightly pear-shaped. Take that, flat earthers. Furthermore, Vanguard 1 made a massive leap in power supply technology by being the very first satellite to use solar cells to charge its batteries, which completely paved the way for long-term space missions.
And when you look closely at Vanguard 1 here, you can really see the exact mid-century engineering that made all those discoveries possible. Those distinct little antennas and the small solar panels proved once and for all that solar power was the future of satellite sustainability. It is just a really beautiful piece of mid-century engineering.
Section 4. Expanding the application spectrum. As we pivot into the early 1960s, the space race entered a whole new phase, moving rapidly from simple proofs of concept to highly specialized tools. And this brings us right back to that weather app on your phone. This is Tyros 1, launched on April 1, 1960. It was the world's very first weather forecasting satellite. Equipped with 2 onboard Vidicon cameras, it took the very first weather pictures of Earth from space. Suddenly, meteorologists weren't just guessing based on local ground data anymore. They had a literal bird's-eye view of global weather patterns, a total game-changer. Now, alongside weather, communication tech was also leaping forward, but it hit a bit of a roadblock. See, early satellites were just what we call passive reflectors, meaning we basically beamed a radio signal at them and it simply bounced off their surface back to another point on Earth. But scientists quickly realized we needed active repeaters. We needed satellites that could actively receive a signal, amplify it, process it, and then retransmit it back down to Earth with real power and clarity. To get a sense of the passive reflector, check out Echo 1, which launched in August 1960. It was, essentially, a giant, shiny, aluminized mylar balloon placed into space. I mean, its only job was to inflate and be reflective. It successfully proved that 2 distantly located stations on Earth could communicate by bouncing signals off a spaceborne object. But, as you can imagine, it was highly limited in how much data it could bounce and how strong that signal would actually be upon return.
But the real breakthrough for modern tech came just a few months later with Courier 1B, launched in October 1960. Covered in those dark solar panels, this was an active repeater. It actually received the signal, processed it, and sent it back. Courier 1B completely solved the limitations of passive reflectors like that giant Echo 1 balloon, and it laid the exact technological foundation for every single modern communications satellite we use today, from television broadcasts right down to secure internet data.
It's genuinely staggering to think about the timeline we've just walked through. In the span of a single human lifetime, we evolved from launching hot air balloons and modified wartime rockets to deploying incredibly complex orbiting radio stars that map our globe, predict our weather, and connect literally every human being on the planet. From Arthur C. Clarke's theoretical math in 1945 to global necessity in the 1960s, the evolution of satellite technology is just an absolute testament to human ingenuity. As our modern world becomes increasingly reliant on this invisible web above us, it leaves us with one provocative question. What limits are we going to push past next? Thanks so much for joining me on this explainer, and hey, keep looking up!